Imagine a customer submits a support ticket about a billing discrepancy. The AI command center springs into action. First, it classifies the ticket as billing issue, using natural language understanding, tagging it with urgency based on keywords like overcharged. The system then drafts a grounded response by querying the knowledge base for similar cases and company policies, ensuring accuracy. If the issue involves conflicting data or requires executive intervention, the ticket is escalated to a human agent with a summary of findings. This seamless flow from inbound request to resolution is the core of the product. The user boundary is simple. Support teams interact through a familiar interface where tickets arrive pre-tagged, drafts appear with confidence scores, and escalation rules are customizable. Inputs are customer messages, email, chat forms, internal data sources, payment systems, user histories, and agent feedback. Outputs are resolved tickets, audit logs of AI decisions, and dashboards tracking resolution times. Behind this workflow is a cohesive architecture built from 5 key repositories. 20 serves as the CRM backbone, structuring customer data, ticket metadata, and workflows as code. It defines how objects like tickets and customers relate, enabling support teams to version control their business logic. Agents Towards Production provides the AI agent framework stateful workflows that maintain context across interactions, vector databases for similarity searches, and deployment patterns for scaling. These agents handle classification, draft responses, and decide when to escalate. Onyx powers the LLM interactions, integrating RAG, retrieval augmented generation, to ground answers in company documentation, web search for real-time data, and custom agent execution. It ensures responses are accurate and auditable. Strapi manages the content layer, exposing APIs for ticket updates, knowledge base articles, and agent notes through a headless CMS. Its role-based permissions guarantee data security. Finally, Daisy UI delivers the front-end, rendering clean, responsive interfaces for agents to review AI suggestions, modify responses, or override escalations, all with minimal cognitive load. Each repository addresses a distinct layer: 20 for data modeling, Agents Towards Production for AI behavior, Onyx for LLM orchestration, Strapi for content management, and Daisy UI for human interaction. Together, they form a production-ready system that reduces manual work while maintaining transparency. The result? Support teams focus on complex cases, not busy work, while the AI handles the rest with precision. When a customer submits a ticket through the front-end built with Daisy UI, the data flow begins with a REST API call to Strapi. Daisy UI's Tailwind-powered components handle user input and validation, then send a structured payload to Strapi's endpoint, say, a post the ticket's API endpoint route defined in Strapi's content type builder. Strapi, acting as the backend CMS, authenticates the request via its role-based permission system, creates a draft ticket entry in PostgreSQL, and returns a TUHA-1 status. This ticket creation triggers a Strapi webhook that sends an event to 20's CRM core. 20, built on Nest.js, receives the event via its GraphQL API, creates a corresponding ticket object, and updates its PostgreSQL database. 20's service layer then emits a ticket-created event through its BullMQ system. The Agents Towards Production framework, listening for such events, picks up the ticket and initiates its classification workflow. Here, the data flow splits. The agent framework uses Onyx as its LLM orchestration layer. It sends a request to Onyx's process endpoint, passing the ticket's text and metadata. Onyx, leveraging its RAG capabilities, queries a vector database, backed by PostgreSQL or Pinecone, depending on config, to find similar historical tickets and their resolutions. It returns this context along with a draft response generated by the configured LLM, for example, GPT-4 or Llama 3 via Ollama. The agent framework evaluates Onyx's output against predefined escalation rules. Maybe the ticket involves a refund over $500 or requires code changes. If escalation is needed, the framework calls 20's API again, updating the ticket's priority and assigning it to a human agent queue. For routine cases, it auto-generates a response in Strapi via PUT, the replies API endpoint, which Daisy UI then polls to display the answer to the customer. Storage entities are tightly bounded, Strapi holds raw ticket content and replies. 20 manages CRM-specific relationships, for example, customer accounts, SLAs. Onyx catches vector embeddings and LLM prompts, and the agents towards production framework stores workflow state in Redis for real-time tracking. Service boundaries are enforced. Strapi never interacts directly with Onyx, and 20 doesn't handle LLM logic. Each repository hands off work through well-defined contracts, like Strapi's CMS APIs for content or 20's GraphQL for CRM state, ensuring the system scales as support teams grow. Start by standing up the backend with Strapi as your headless CMS. Use the Quick Start command to scaffold a project, then define content types for tickets, users, and knowledge base articles. Wire up PostgreSQL for persistence since it's battle-tested and familiar to most teams. Fire up the development server with npm run develop and confirm the auto-generated REST APIs are accessible. Now layer in Onyx for LLM capabilities. Docker Compose makes local setup straightforward. Configure its RAG features to connect with Strapi's API, pulling ticket data and knowledge base content into vector indexes. Test the integration by querying Onyx directly through its UI to ensure it retrieves relevant information. Next, scaffold the support agents, using the agents towards production tutorials. Clone the repo, install dependencies, and run the stateful workflow demo to understand how memory and actions chain together. Modify the agent templates to interface with Onyx for answer generation and Strapi for ticket updates. Use the local CLI tool from 20 to generate CRM objects for tickets and workflows. Define views that show ticket status, assigned agent, and AI-generated response drafts. Use the 20 CLI to seed initial data and verify the CRUD operations work through their admin interface. For local development, run all services in Docker containers to mimic production parity. Use Docker Compose up with Onyx, Strapi, and 20 services. Set up port mappings and environment variables for API keys and database connections. Use a tool like Tmux or Docker Compose exec to tail logs and debug issues in real time. For background jobs like classifying tickets or escalating stale ones, leverage BoolMQ with Nest.js from 20's stack. Define queues for classification and escalation, then write handlers that call Onyx for intent detection and priority scoring. Test jobs with BoolMQ dashboard to monitor progress and retrieve failures. Production deployment starts with containerizing each service. Build Docker images for Strapi, Onyx, and 20 with multi-stage builds to minimize size. Use Kubernetes for orchestration, setting resource limits and readiness probes. Deploy to a managed PostgreSQL instance and set up backups. For the front end, use Daisy UI components by installing via npm, then customize themes using their class modifiers. Build the static assets and serve them through a CDN. Set up CI/CD pipelines with GitHub Actions to test and deploy on merge to main. Test the MVP end-to-end. Submit a ticket through the Daisy UI frontend. Verify it creates a record in Strapi. Check that the classification job processes it. Confirm Onyx drafts a response, and ensure escalation triggers when thresholds are met. Use Postman or curl to validate API responses. Monitor with Sentry for errors and use logging aggregators to track agent performance. Iterate based on support team feedback, adding plugins to Strapi or custom agents as needed. This order balances speed and scalability, letting each tool handle its core strength without premature optimization. To tie this system together, start by standing up the 20 CRM backbone. Clone the repo, then run Docker Compose up to spin up PostgreSQL Redis and the core services. Set 20 env production in your env to ensure settings align with live environments. For Strapi's headless CMS layer, initialize a new project with npx create Strapi app at latest support CMS, then define ticket categories and knowledge base schemas via the content type builder. Use Strapi admin panel add-ons to enable the AI content generation plugin for auto-drafting responses. On the LLM side, deploy Onyx via Docker. Docker run p3000 Onyx port 3000 onyx.app Onyx. Configure connection strings for your LLM provider. For example, Onyx Alma Opine API key your key, and enable RAG integration by setting Onyx RAG enabled true to ground answers in ticket data. For the front end, install DaiGui with npm install DaiGui, then import components into your React app. No extra CSS frameworks needed. Agents towards production requires Docker Compose for multi-agent workflows. Clone the repo, edit the env to set agent log level debug for troubleshooting, then run Docker Compose upd to start the FastAPI backend and worker nodes. Note that GPU scaling via agent GPU1 demands CUDA-compatible hardware. All components are open source. 20 uses a custom license, Strapi and DaiGui are MIT, Onyx is a patch 2.0, and agents towards production leans permissive. Self-hosting is free but demands infrastructure. 20 offers a managed cloud alternative. A developer could today clone agents towards production, run npm install g at agents towards production cli, then execute app init support agent to scaffold a ticket classification agent. What's the best practice for securing agent to database connections in production?